Welcome back to ThinkCosmos. Today, we're diving into something rarely asked, yet deeply fascinating. What does the universe sound like? We often think of space as silent, a dark, cold void where sound cannot travel. And that's partly true. In the vacuum of space, there are no air molecules to carry sound waves like they do here on Earth. So if you were floating next to an exploding star, you wouldn't hear a thing. But here's where it gets interesting. Just because sound can't travel in space the way we experience it on Earth, doesn't mean the universe is silent. In fact, space is filled with vibrations. And those vibrations can be translated into something our ears can understand, through a process called sonification. Let's rewind to the beginning. When the universe was just a few 100,000 years old, it was a hot, dense soup of particles. In this early phase, the universe was actually small and dense enough for sound waves to ripple through it. Acoustic waves that echoed through space itself. These are known as baryon acoustic oscillations. They left imprints in the cosmic microwave background, the leftover light from the Big Bang, which we can still detect today. In other words, the early universe rang like a bell. NASA scientists have taken data from these early ripples and converted them into sound. And when you listen to them, it's haunting. A low, eerie hum that slowly rises and falls, like the breath of the cosmos itself. But that's just the beginning. We've also recorded the sounds of planets. Jupiter, for example, emits powerful radio waves caused by its intense magnetic field. When converted into audio, these waves sound like a chorus of electrical storms, otherworldly and alive. Saturn sings too. Its rings generate as subtle vibrations as particles collide, producing gentle, shimmering tones. Black holes. They create real waves, not sound waves, but gravitational waves, ripples in space-time itself. In 2015, scientists at LIGO detected gravitational waves for the first time, caused by two black holes colliding over 1 billion years ago. When translated into sound, it created a quick, rising chirp. Got a cosmic heartbeat. The sound of space-time itself warping under massive gravity. So, even though space is silent in the traditional sense, the universe is far from quiet. The entire cosmos is vibrating with energy, radiation, and gravity. And we now have the tools to hear it. Astronomers have begun turning light, radio, X-rays, and even magnetic field data into immersive soundscapes. These sonifications allow us to experience galaxies, nebulae, and supernovae, not just with our eyes, but with our ears. Imagine a galaxy cluster, its thousands of stars transformed into cascading piano notes, or a black hole pulling in material, rendered as a deep, slow pulse. It's not just art, it's data converted into frequency and pitch. And it helps us understand the universe in new ways. Blend scientists and students are using sonified data to analyze cosmic patterns without needing vision. And even researchers with sight are discovering things they couldn't see, but could hear. So what is the sound of the universe? It's not what Hollywood makes it out to be. No Star Wars-style explosions in deep space. No rumbles across the void. Instead, it's a symphony of signals. Hidden vibrations, cosmic echoes, and gravity's song. It's ancient sound made new again. Unheard frequencies translated by technology, revealing the music of the cosmos. And perhaps most amazing of all, it's a reminder that the universe isn't just a place of silence and distance. It's full of rhythm, structure, emotion. A place that doesn't just move, but resonates. So next time you look up at the night sky, remember, you're not just seeing stars. You're standing in the middle of a concert that's been playing since time began. Thanks for listening to another journey with ThinkCosmos. If you found today's episode inspiring, subscribe for more stories from the outer edge of space, time, and thought. Until next time, stay curious and keep listening to the stars.